Well, it's certainly been a busy few weeks here with this and that, and I've eventually managed to complete my workshop, and I've been contemplating what to do next for my next project. And I did sort of have my heart set on making a red wing from castings, and I was waiting for some stock to come into the country, and I then sort of realised that maybe my little mini mill won't be up to it, because I just don't think it's got adequate capacity. So I had a rethink, and I decided to have a go at making a hit and miss engine from bar stock. And what I've decided to go with is a set of plans of the Jerry Howell Farm Boy. Now these plans are copyright, which is fair enough, because I think Jerry Howell's son actually makes a living out of selling them. But he did advise me when I contacted him that it was okay for me to show this first page. Obviously, I won't divulge the contents of the following pages, of which there are many. I think it finishes on round about sheet 21. Now I bought some bar stock just to set me going, and that's for part of the body, and this is for part of the body. But again, then it dawned on me that this actually needs to be cut in half, and there's no way I can tackle that with a hacksaw. So what I've just gone and done is ordered a horizontal bandsaw. So hopefully that will arrive in the next few days, and that should be fun putting that together. It's one of these cheap ones from China, but it sort of gets decent write-ups. It's a Warco model. But anyway, I really want to sort of get on with this new project, and I think on page 10 it covers the making of a couple of gears. So in this video I'm going to have a go at making these two gears, and I've never made a gear before in my life, so it should be interesting. So having looked at the plans, to be honest, the terminology is totally unfamiliar to me. It's like a foreign language. So what I decided to do is to refer to this book here that I bought probably about 12 months ago. And when I first opened it, I had a read and then put it back on the shelf because I didn't understand it. So I've been sort of going through this again, trying to sort of learn the terminology and the maths, and also in association with the Metalworkers data book. Now, in the actual plan, there are two gears to be made. One is a cam gear and the other one is a crankshaft gear. The crankshaft in mild steel and the cam gear in brass. Not sure why that should be mild steel. Maybe because it's smaller, there might be more torque on it. I don't know. But anyway, just to run through this, the plan actually says that it's got to be, you use 48 pitch or 48 DP cutters, and you need to make a blank with an outside diameter of 0.1542 of an inch, and you need to cut 72 teeth. Now, just to double check on the maths, the pitch, the DP, I think it's diametrical pitch, could be wrong, is equal to the number of teeth plus 2 divided by the outside diameter. So that means that we've got 72 plus 2, 74 divided by the outside diameter, 1.542 is equal to that, which is pretty close to 48. So I'm happy so far. Now, the pitch diameter, which is the it's the diameter of where the teeth actually make contact between the two gears. So it's less than the outside diameter. but greater than the diameter where the bottom of the tooth is, if that makes sense. So the pitch diameter is calculated as being the number of teeth, 72, divided by the DP, which is 48, which gives 1.5 inches. Now the crankshaft gear, this has got an outside diameter of 0.0792, a pitch of 48, which it has to be, the pitch has got to be the same for both gears, and number of teeth 36. Now again, doing the maths, the pitch diameter works out to be 0.75 of an inch. So down here you can work out the distance between the centres. So you take 1.5 plus 0.75, divide it both by 2, and you get 1.125. So that's the distance between the centres for the teeth to engage properly. And in the plans it says that the depth of cut for a 48 pitch cutter is 0.045 of an inch. So all good to go so far, until I tried to buy some 48 pitch cutters. Now I found one supplier that had a number 3 cutter, but they didn't have a number 2 cutter, and I couldn't find any other suppliers that had those cutters. So that led me to thinking that maybe I need to try and convert from 48 pitch to one of the modules, and having read up on this, I think the closest you can get to 48 pitch is the mod 0.5. So the deep, so if I was to take no, hang about. So the DP is equal to apparently 25.4 divided by the mod, so that comes in at 50.8. Now for the maths again, the outside diameter is equal to the number of teeth plus 2 divided by the DP. So I looked at various sizes of this cam gear, and I ended up coming up with 78 teeth. So for an outside diameter calculation of 78 teeth, you divide 78 by the DP, which is 50.8, which comes in at 1.5354 inches. Converted to millimetres is 39 millimetres outside diameter. Alternatively, another way to calculate it is number of teeth plus 2 multiplied by the mod, and then that comes, so that's 78 multiplied by the half gives you 39. Now the let me see, the pitch diameter, which is where, this is where the ring where the teeth join for the 2 gears to work properly. So the pitch diameter is equal to 76, because we've got 76 teeth, divided by the DP, which is 50.8, which gives you 1.496 inches, which is equal to 38 millimetres. Now for the smaller gear, obviously if I'm going to go with, let me see, 78 teeth on this, I need to halve that because it's a ratio of 2 to 1. So I need to go for, no sorry, if it's the 76 teeth, I need to halve that, which comes in at 38 teeth for the smaller one. So on the same, using the same maths, the outside diameter of 38 teeth is equal to T plus 2 divided by the DP, which comes in at 20 millimetres outside diameter. Now the PD is equal to 38 divided by 50.8, which is equal to 0.748 inches, which is equal to 19 millimetres. So for the distance between centres, it's 38 plus 19 millimetres divided by 2, which equals to 20.5 millimetres. So if I'm going to go with a mod 0.5, I'm pretty confident that this combination will work. We're quite close here. The distance between centres of 28.5 compared with on the ones in the plan, that ends up being 28.575. So on that basis, I'm going to go with mod 0.5. Now, until today, I'd not bought any gear cutters, but these arrived today from China. I've read some write-ups where people say these aren't very good, but I'm a bit reluctant to pay £80 each, especially when I don't really know what I'm doing. For these, the depth of cut actually needs to be 1.08 millimetres. So we'll go over to the mill or the lathe and see how to progress it. Okay, so what I decided to do off camera is to make the gear blank for the smaller crankshaft gear, and this should be mild steel, but as a test I thought I'd try it out in brass. So I won't actually use this on the machine, but if this works out okay, I'll just duplicate exactly what I'm doing here. So I've cut it to the right dimensions, and we've got an outside diameter here of 20 millimeters. Now it's attached to the rotary table. It's in a collet. I've put it on this mandrel, and it's supported here by this. And I'm going to use this controller that I made in one of my previous videos to actually turn the shaft so many degrees at a time. I think you just put in the number of teeth and it'll turn it, it'll calculate the number of degrees. Now I've put the correct cutter on this, and what I'll do is I'll position the cutter halfway down. I'll do it off camera actually because it's a bit tight. I'll make sure it's spot on centre, and I'll touch the teeth on the edge of the blank, and once I've done that I'll move the table to one side and I'll advance the cutter in by 1.08 millimeters, and then we can commence cutting. Okay, so this is very exciting. So I've set the depth to 1.08 millimeters, and as the cutter will be turning that way, I need to move the table that way to make a cut. And I've set the World of Ward controller to 38 divisions because there's 38 teeth, and we'll give it a try. So I'll lock the table first of all. No, in fact what I'll do is I'll go forward once. Right, now I'll lock the table and I'll make the cut. Not too sure what cutter speed to go at here. Let me see. 5:10 at the moment, see what happens. Okay, so far. Now unlock the table and go to the next one. Lock the table and repeat. I think I might increase the speed actually. Up it a bit. Unlock the table. Next one. Lock it. That's looking promising. So I'll continue and I'll get back to you later. Well, that looks pretty good. Quite happy with that. Now it does look as though I might have just had the cutter slightly off centre. So next time I cut a gear I need to make sure it's spot on centre. But apart from that, pretty impressed. So what I'm going to do now is to make the cam gear in brass, and then I'll repeat the same process I did for the crankshaft gear, but I'll make it in mild steel. Reduced down to 39mm in diameter. Well, that's the first time I've used that parting tool, and to be honest, it cut like butter. Okay, so this time I've really taken my time on making sure that the cutter is central to the blank, and I've also just turned the cutter and the x-axis just to make sure that the cutter just touches. So now I'm happy that I can move the y-axis by, what is it, 1.08mm. It's worth noting that this blank is spot on 39mm. If it wasn't, then I'd have to adjust the 1.08mm to compensate for that. Okay, so that's set to 1.08. So I think everything's set. I've set the controller to 76 divisions for 76 teeth, and we'll give it a try. I'll move it forward one, lock it, and cut.
lock it, forward, lock it. Those look pretty good, so I'll continue off camera and then I'll catch up with you later. Hey, that looks good. There's a bit of work to be done to make that look a bit prettier. Just some holes and put a recess in it, I think. But I can do that off camera on the rotary table. And this gear here, what I'll do is I'll just remake that in mild steel, and then I'll get back to you. Well, I remade the smaller crankshaft gear in mild steel, and I've just drilled a couple of holes in this piece of aluminium, 28.5 millimetres between centres, which is what I calculated. And I thought I'd set this up just to give it a bit of a test. So let's see how it works. Well, I'm very happy with that. Well, I don't know whether I've bitten off more than I can chew with this new project. I mean, there's so many components to a machine, and so many sort of challenges along the way. It's probably going to take me months, hopefully not years, but who knows. But making these gears has been really enjoyable. It's something I'd fancied doing for quite some time and never had an opportunity to have a go at it. I'm really happy with the way my little controller worked on the rotary table, and I'm over the moon with the result. There is some more work to be done on the larger gear. I need to put a cam on that, but that should be fairly straightforward, and it needs to be prettied up a bit. But anyway, I hope you like the results so far, and I hope to see you later.